Question number 2, in the figure below, points G and P are on the line segment N to H. Triangle NOP, N to O to P, this big triangle, is equivalent to rectangle NPQR, N to P to Q to R, shaded in rectangle. N to G is 225 centimeters. G to P is 64 centimeters. We want to find the altitude of this triangle in order to figure out the area of the triangle. And once we know the area of the triangle, then we know the area of the rectangle. Once we know the area of the rectangle, we can figure out the height, N to R, which is the same as P to Q. And that's the altitude of this triangle. And once we know the altitude of this triangle, we can then figure H to P. The altitude squared is equal to the orthogonal projection of the small side onto the hypotenuse times the orthogonal projection of the big side onto the hypotenuse, which means G to O, that's the altitude, squared is equal to G to P times N to G, or G to N. G to O is what we don't know. G to P is 64. N to G is 225. G to O is 14,400. Take the square root of which is 120. G to O is 120. We can figure out the area of this triangle. The area of the triangle is base times height divided by 2. 224 plus 64 is 289 times the height times the 120 divided by 2 gives us an area of 17,340 centimeters squared, which is the area of this rectangle because they're equivalent. The area of the rectangle is the base times the height, Q to R times N to R. Q to R we know is 289. N to R is the height. Divide both sides by 289. That's going to give us 60 is equal to N to R. We know this is 60, which is now the altitude of this small triangle. The altitude of the small triangle is the orthogonal projection of the small side times the orthogonal projection of the big side. P to Q is 60 squared is equal to H to P times 64, which gives us 3,600 divided by 64 is H to P, which is 56.25 centimeters is H to P. And that's it for question number 2. Have a good day.